Hey, what's up, guys? Welcome to the channel. And in this particular session, we will be looking into insertion sort. Okay, we'll be understanding it in a very easy way. Okay, so if you have difficulty understanding insertion sort before, that will be get clarified in this particular session. So stay tuned till the end, and I have taken a target of 10 minutes to explain the insertion sort. We'll be starting the timer, and then we'll seeing that if we are able to complete the insertion sort or not. So this is a sorting algorithm. This is one of the basic sorting algorithms what we have, and the complexity of this sorting algorithm um, is O of n square. It's not preferred, but it is very good to know the two of the sorting algorithms. One is the insertion sort, and one is the selection sort, which we will be seeing in the next session. Okay, so the basic no crux of an insertion sort and why it is called insertion sort is we insert a particular element. So in an unsorted array, we divide the array into two parts. One is the unsorted array and one is the sorted array. We take the element from the unsorted array and place it in the sorted array in the correct position. Okay, so you can see the visual over the screen, right? So that's basically what is done in insertion sort. Okay, and and we'll be seeing this in a very simple way, so that it's very you grasp the concept and you don't forget it. Okay, so let's see that, and we'll be starting the timer now. Okay, and let's get started. So it's a very simple algorithm. As I told, the whole unsorted array is divided into two parts. One is the sorted array and one is the unsorted array. We take elements from the unsorted array, okay, and place it to the sorted array. So you can see initially the sorted array was only one element, okay, and then the sorted array, the sorted part of the array started growing, okay, as the new elements were getting inserted into that particular array. So of all sorted array, okay, or of all elements of the sorted array, first is sorted, second is unsorted. This is assumed, and then first element is placed onto sorted. Okay, you can see that now 4 is placed to the correct position. Now 6 is placed to the correct position. Now 1 will be placed to the correct position, and this placing, when we say we are placing it, so we are basically comparing and swapping at the end with the correct position. Okay, so we'll be seeing the code is also very simple. We'll be just looking that in a moment. So let's see an example of it. Okay, so we'll be taking an array, okay, and that array is 85, 12, 59, 45, 72, 51. So this is an unsorted array, right? And this you can see in the first place it is unsorted, and at the end we are making it sorted, right? We are making it sorted with some iteration. So let's go through it very quickly. As I told, we'll be dividing the whole array into two parts. One is the unsorted part, one is the sorted part. So 85 is assumed as sorted, and the rest part from 12 to 51 is assumed as unsorted. Now we start from 12 and see what is the correct position in the sorted array. So 85 is already there, so you will be placing 12 before 85, right? And in the first iteration. In the second iteration, we will be going to 59, placing the 59 to the right position in the sorted array. So the sorted part, so 12, 14, 12, 59, 85 is now sorted. Similarly, you will be placing 45 to the correct position, and you can see how the sorted array is growing, right? It will be growing at the end of all the iterations, right? You can see we have done the iterations for each of the elements, and at the end you can see the array gets sorted, right? So this is basically the insertion sort algorithm. This is very simple algorithm, okay, and the time complexity of this particular algorithm is O of n square, okay. And as I told, this is not very optimum sorting algorithm. We will be seeing quick sort, merge sort, which is far better than this particular algorithm. But for sake of knowledge, you should be aware that what an insertion sort is and why it is called an insertion sort. Okay, I think this would have made a lot of sense, whatever we have taught. So let's look into the code part of it. Okay, so the code is also very simple. We will be creating a normal class in which we will be writing the sorting algorithm. Okay, I have created a sorting interface, and that will be writing the sorting logic. Okay, we take the array and it sorts in place. Okay, so the sorting will be done in place. So the code is very simple for this particular algorithm. Okay, as I told, we divide the whole array into two parts. One is the sorted, one is the unsorted one. And from unsorted array, we take elements one by one, and we keep on inserting that to the sorted array. Okay, so you can see on your screen from line number 6. Okay, line number 6. Basically, we have started uh, doing the sorting implementation. So let's run it first, and then probably we'll explain the algorithm once again when it comes down to the screen. So this is the runner, which is taking the insertion sort, and which will take the input array which is provided above, and which will be sorting that particular algorithm, right? So you can see the array which was given is used for sorting, and we'll be just running this to get you look and feel of how this sorting array looks like. Okay, so you can see after running this application, the array gets sorted. You can see the elements over the screen, right? 0, 1, 2, 2, 3, 3, 3, 3, and all. So this gets sorted. Okay, so this is basically the insertion sort algorithm. Okay, and if you look very closely of what is happening in this algorithm, okay, from line number 6, right, you can see that we are traversing through the length. As I told, the first element will be treated as a sorted array. So I have taken the and I have stored that in an variable called element. So that element, that first part will be the sorted array, and now you will be inserting considering that particular element. Okay, so you can see at line number 8 we have taken the first element. Now we have started from 1, the loop is started from 1, and the next loop which will be iterating through will be from will be within the sorted array, and we will check where the correct position for that array, element is, and we will be just inserting that. You can see the value of input of j is getting inserted at input of j plus 1, so that value will get added to the correct position, and this algorithm works just fine. So this is a very simple algorithm. Okay, and you should be aware what an insertion sort is, so I just thought of creating a very quick video around it. So hope this was helpful. There will be a lot more videos to come. Okay, there will be 3 4 sorting algorithms. So one will be quick sort, merge sort, which is very optimum in nature, optimum performance in nature, and after that we will be seeing the other data structures. Okay, so these were the tools for the algorithms. So thanks for watching. Take care. Bye bye.